So a progressive wave is defined as any wave which can be propagated from one region of a medium to another. So any wave, a progressive wave, is any wave which can be propagated from one region or from one point. Let me use point. From one point of a medium to another. To another point, let me qualify it a bit. To another point within the same medium. So when ocean wave starts, when an ocean wave starts from a point within the ocean, it can continuously be propagated through the water medium till it ends up at the seashore. So the point or the starting point is the region within the water where the wave actually starts, continues throughout, and then ends at the shore. Okay, so any wave which can continuously be propagated from one point or area or region of a medium to another is termed as a progressive wave. Now for progressive wave formation, note. Any wave which can continuously be propagated from one point of a medium. Hey, Angel, mute yourself. Any wave which can be propagated from one point of a medium to another point within the same medium is known as progressive wave. So for progressive wave formation, for progressive wave, the medium must be so big or large or large, vast medium, so that the energy starting from one point would continuously be propagated within the same medium. So energy is continuous within the medium. Now note that the measure of the energy carried by a wave is determined by the amplitude. The measure of the energy carried by a wave is determined by its amplitude. So if you want to determine the energy, carried by a wave determine the amplitude. Its amplitude. So practically, you see, when you go to the beach and there is an oncoming wave, usually the size of the wave on the surface of the water will determine whether you are to run away or stay there. So when you realize that at the height of the wave from the surface of the water, the equilibrium position X, when the height is so big, nobody would advise you to run away for your dear life, because the height alone tells you that, hey, this wave can just topple me over and then drown me. So let me run away. So what informs your decision to run or stay is this height above the water surface. So the energy carried by a wave is determined by its amplitude. Amplitude A, which is also the same as this measure below, from either from equilibrium point to crest or equilibrium point to trough. They are all amplitudes. Okay. Nathaniel, mute yourself. Now, whenever we draw a wave profile, we draw it to look as if as the wave continues within the medium, its amplitude is the same throughout. So look at what I've drawn. It always appears as if its height from the equilibrium position is the same throughout. This is a theoretical consideration. Whenever we do theory, we draw a wave to look as if it has the same amplitude. So we call this as free oscillation, as if it's a free oscillation. So in a free oscillation, the amplitude of the wave is the same throughout. Practically, no. That is now how it is. Practically, as a wave is propagated within a medium, as the energy continues to be sent through the medium, the amplitude drops. We call this damped oscillation. So in damped oscillation, the amplitude is not constant throughout, but it drops. This is because part of the energy can be lost through friction, can be lost through air resistance. Okay, so, and then can also be lost due to interaction with other molecules. So damped oscillation occurs due to the consistent decrease or damped oscillation occurs as a result of, or when damped oscillation occurs when the amplitude, when the amplitude of the wave or of a wave continues to decrease. to decrease as a result of one, collision between molecules or atoms of the same substance let me use material. Then due to friction, and 3, due to air resistance. So these are things that can possibly cause damp oscillation. So in damp oscillation, as the wave travels or is propagated, you realize that the amplitude starts so big. As it moves on, the amplitude will be dropping, and then will fall to a very small value. Practically, this is what happens. So you see, when you visit the beach, the size of the wave, which when it started, made the decision for you to run away, it means that wherever it started, the amplitude must be very large. So imagine you see a wave coming and you are running away. Then what it means is that at the point of its beginning, it was actually a monstrous wave. So as the wave continues, there's loss of energy, the energy due to interaction between air molecules, okay, the water molecules due to air resistance, okay. Here friction is less. We can't talk about friction. In the case of a wave, we can only talk about interaction or collision between water molecules and then air resistance. Part of the energy, propagated energy will be lost. And so you realize that the amplitude continues to decrease. This is what we call damped oscillation. But in free oscillation, I said it's a theoretical concept. The wave profile is drawn as if nothing is lost. Please, are you with me? Class, are you there?
Yes, sir.
And this is what happens whenever you oscillate a simple pendulum and then you displace it at a large angle. So in simple pendulum experiment, the precaution is that the angular displacement or the pendulum bob must be displaced at small angle. Theta must be very small. If theta is not small, we'll have a situation where the amplitude of oscillation will be decreasing with time. The amplitude of oscillation will be decreasing with time and it would affect our experiment. So that is why in simple pendulum experiment, we are advised to displace the bulb through small angle in order to prevent damped oscillation, where the amplitude will be dropping with time. Please ask your questions if you have any. Okay. Once there is silence, then it means you have nothing to ask. Let me check on attendance. So, Leslie, Adoma, Angel, Darius, Elsie, Efia, Esther J, Fifi, Frida, Frederick, Glenn. Okay. Okay, so let's move on to progressive wave equation. So to form a progressive wave, the medium must be so big. And progressive wave in itself is any wave that can be propagated from one point of a medium, okay, continuously to the other point or region of that same medium. So if a wave, if any equation of a line has an equation, then we are saying that a wave profile is sinusoidal. It has the shape of a sine graph or cosine graph. So x is the displacement of the wave. Hey, what an amplitude of a wave. It must curve a little. Please, when you are drawing this, add aesthetics to your drawing. And here we are only considering free oscillation, free oscillated wave. Hey, yeah. This is the origin of the wave. Oh. Let's also consider a particle vibrating, a particle P vibrating at this point. This wavelength of the wave, we don't know. So let the wavelength be x. This phase, the phase difference between the origin and this point, we don't know. So let that be phi. For a full wave lambda, for a full wave lambda, or for a full wave, its wavelength from the origin is equal to lambda. Okay. This point has a phase angle of, or phase difference from the origin equal to 360 or 2 pi. Okay. Now, a wave is formed as a result of vibration of particles. So if we are looking at particle vibration starting from the origin, then because a wave is a harmonic, simple harmonic function, the equation of the wave, the equation of a wave starting from the origin origin O takes the equation of a simple harmonic motion. For simple harmonic motion starting from the origin, the equation is either y is equal to a sine omega, this is omega t. Okay. So when a wave starts from the origin O, then its equation, its displacement equation, it's the displacement equation of a wave starting from the origin O is given by either y is equal to a sine omega t or y is equal to a cos omega t. So if it's just this, then Lizzie, Frida, Kelvin, it means that the wave starts from the origin. Now, when we are looking at a particle P vibrating at a distance x from the origin, how do we write the equation? So, what is the displacement? The displacement equation of a particle P vibrating at an angle far away from the origin. So when the particle is vibrating at O, its displacement equation can be this, any one of these equations. And when it is vibrating at a point P, which has x length of a wave away and phase angle far. Please, this phase angle is important because if we are looking at a particle vibrating here, the phase difference is the angle between the origin and then the point of vibration. And that is what we saw as the phase constant. That this will be 90. When the particle vibrating at this point, this is 180, which is also pi. A particle vibrating at this point has a phase constant of what is 270 in radian? What is 270 in radian? Class, what is 270 degree in radian? Quick one. Oh, Ayo and Co, 270 degrees in radian. Hey, no one is talking, or you cannot hear me. Change 270 degree in radian. Hey, Fifi, Papra, Frida, and Co, I've asked a question. Julian, respond and let's continue. 270 degree in radian. Oh, you can't hear me. Please, I always say that you do not waste time when there's a need for you to respond. So 3 pi on 2, and then this is 2 pi. This point, we have no idea. So let the phase constant or the phase difference between be fine. Okay. Now, when the wave starts or the external energy hits the medium, when the external energy hits the medium, particle O vibrates before particle P. Okay, when external energy hits the medium, particle at the origin O vibrates before P, meaning in terms of vibration, particle O leads particle P. In terms of vibration, particle O leads particle P. This is just because particle O would vibrate first before the energy gets to particle P. So in terms of vibration, particle O leads P. So if we want to write the displacement equation of P, so displacement equation of P because O from the origin leads P, you must subtract the phase angle of P from O. And we are subtracting because in terms of vibration, O leads P, or P is behind O. So we subtract the phase angle of P from O. What is the phase angle of O? That is omega T, which is the same as theta. Don't forget, in simple harmonic motion, theta is also equal to omega T. So instead of omega T, let's use this. So we are subtracting the phase angle of P from O. And what's the phase angle of P? That is phi. This symbol phi, which I've indicated here. Okay, so why are we subtracting? We are subtracting because O leads P in terms of vibration, or P lags behind O. Class, are you okay with the explanation as to why we are subtracting? Are we okay? Give me feedback.
Yes, please.
All right. So y therefore is equal to A sine. Please let me take short of attendance and upload it on the platform. Okay. Okay, so theta is omega T minus phi. And what is phi? Let's look at something, ratio and proportion. The wavelength lambda is to a phase angle of 2 pi. So a full wave has a phase or difference of 2 pi from the origin. Then x length of a wave, we don't know its phase angle, so we say let that be phi. So when we take ratio and proportion of these two, lambda over 2 pi is equal to x over phi. Let's then make phi the subject. Frida, help me make phi the subject from what I have on the board. Frida, help me make phi the subject.
Please 2 pi x over lambda.
Thank you. So phi is equal to 2 pi x over lambda. So we have expression for phi in terms of full wave and the unknown length of a wave x. Please, if you are writing, quickly do that so I can flip to the next page. When you finish, let me know, please, so as to save time. Are we done?
No, please.
Okay.
So please you can change it.
Okay, so we have y is equal to a sine omega t minus the phase difference phi. Please, let me define something where A is equal to the amplitude of the wave. The whole of omega t minus phi, please note that this is equal to just phase angle, theta. This is known as the phase angle of the wave. Okay, so please, I'm writing this because you have y is equal to a sine theta. Theta is the phase angle. So it means that the whole of this within the bracket is equal to theta, which is the phase angle. Phi is the phase difference. Phase means angle or direction, phase difference. And this is the angle, the angular difference between a particle at the origin or equilibrium point and then another particle vibrating away from the origin. So the angle between them is phi. So phi is the phase difference. Okay, so if y is equal to this, and we've had expression for phi. Phi is 2 pi x over lambda. Then this coefficient 2 pi over lambda is equal to a constant k known as wave number. Wave number. The number of complete wave propagated within a given time. So it means that we can express this as A sine omega t minus k times x. This is the first progressive wave equation. The basic or the first progressive wave equation. So we can expand it. If we expand it, we'll have y is equal to A sine of, we know omega to be 2 pi times f. So we are substituting omega, and let's also substitute k, 2 pi over lambda x. The beautiful thing is that we can factorize out common terms. We can pull out 2 pi, then within a bracket we have f times t minus x over lambda. This is the second form of progressive wave equation. The second form of progressive wave equation. Quickly write it and let's continue. Priscilla Edward. Priscilla. Are we through?
Yes, please.
Okay. Another form of progressive wave equation can be written, and that is, you see, f frequency is equal to 1 over the period. So if we substitute 1 over t for f, we have another form of progressive wave equation. So we have A sine of 2 pi out, then 1 over the period times t minus x over lambda. And this will give us A sine, either when we push in 2 pi t over big T minus 2 pi x over lambda. Whether you factorize or put it in, the value is the same. So this is another form of progressive wave equation. A progressive wave equation can also be obtained when we substitute. We know frequency, the speed of the wave is given by frequency times the wavelength. So if we make f the subject, we have v over lambda. So that when we substitute f into the equation, we have y is equal to a, let's push in 2 pi. 2 pi, f is v over lambda times t minus 2 pi this. So that we have a sine of 2 pi vt over lambda times 2 pi over lambda x. And this is also the same as a sine of 2 pi out vt over lambda. We can also pull out lambda minus x, another form of progressive wave equation. So there can be a lot of equations we can write, and it's just about substituting values. Okay, knowing one, you substitute the other, and it's really not difficult. Please, is there any question?
No, please.
Okay.
Someone has sent a message.
Oh, I think it was. Okay, let me check. And don't worry, I will address it. Crispin, I'll talk about it. Okay, so I'll address it, okay? All right. So let's move to, can I flip to the next page?
No, sir.
Okay. Can we continue?
Yes, sir.
All right. So note that the basic form of it is this. Y is equal to a sine omega t minus kx. Now, please, it can also be y is equal to a cos omega t minus kx. This is because any harmonic or repeated function can be expressed as a sine or cosine. If instead of y you see x, they are all for displacement. So it can also be this. Now, how did we come by this? If we go back to the equation, the progressive wave, I said that the energy starts from this point, hits particle O first, and then moves to hit particle P. So by this, it means that the wave is moving from left to right. Okay, because it is starting, energy is here, hitting the medium, hits the first particle at the origin, comes to this point, on and on. So with this, it means that the wave is moving from left to right, or moving away from the mean point. So if you see a minus or if we subtract the phase constant, or the phase constant, when you subtract the phase constant, and here our phase constant is phi, which is also represented by kx, then it means that this implies that wave is moving from left to right. Wave is moving from left to right, or wave is moving away from the mean point, or the wave is moving away from the mean point. Mean point O. Okay. So if you see a minus, let's go back to our diagram. Now, if the energy is being propagated in this direction, from right to left, particle P this time vibrates before O. So in terms of vibration, particle P will lead O, and the progressive wave equation, the progressive wave equation when the wave is from right to left, is, earlier we subtracted P from O. This time we'll add P to O. So the progressive wave equation will simply be A sine theta plus phi, or Y equals A cos theta plus phi. So if we add the phase constant to omega t, then it means the wave this time is being propagated from right to left, or the wave is moving towards the mean point, or wave is moving towards the mean point. And the equations will be the same. If it's sine, we'll have y is equal to A sine omega t plus kx as the basic. So we can expand to A sine of 2 pi ft plus 2 pi over lambda x. Okay. So the only difference is that if it is plus, if the phase constant is being added, then the wave is moving from right to left or moving towards the mean point. If it is minus, the wave is moving from left to right or moving away from the mean point. That is all. And don't forget, I said it can also be cosine because all repeated functions for which a wave motion is one of them can be expressed in sine or cosine. So whatever trig function you are given, you must express it as such. Please, if you have any question, ask before we apply it to solving problems. So this is the progressive wave equation. And so that is what I was drawing your attention to, that for a simple harmonic motion, Elizabeth, you can be given y is equal to a sine omega t, or y is equal to a sine omega t minus a phase difference or a phase constant, and y is equal to a sine omega t plus 5. Whichever one they give to you, you must work with it. Elizabeth, are you here? Is it? Okay. Let's see how to look at how we can apply this in solving problems. How do we use this to solve problems? I'm going to give you a typical wave question. Please, I'm going to read. Okay, a wave is represented by the equation. A wave is represented by the equation Eva, are you there? It's given by the equation 7 sine 40 pi t minus 8 pi x, where y is in meter. Where y is in meter. Question 1. Find the amplitude. You are to find the amplitude. I. The frequency. The frequency. The period. The period. IV, the wavelength. The wavelength. V, the speed. V, the speed. And VI indicates direction of wave. Indicates direction of wave. I'm giving you 5 minutes to see what you can do. After that, we discuss and you use that to assess what you've done. Class, is that okay?
Yeah, please, can you repeat the question?
So a wave is represented by the equation y is equal to 7 sine into, open a bracket, 40 pi t minus 8 pi x, where y is in meter. Find I, the amplitude, I, the frequency, I, the period, IV, the wavelength, V, the speed, and VI indicates direction of wave. That's the problem of the day. Start work. 5 minutes is over. So let's see it. So if this is the question, how do we solve it? You compare the question given to you to the general progressive wave equation formula. What we are given is sign. So you must write a general formula in terms of sign. So we have A sine omega t minus kx. So when you compare, clearly it means that the amplitude A is equal to 7 meters. We are told that y is in meters, so 7 meters. The next question, the frequency. Frequency can be obtained from omega t. So this part is equal to this part. Or you can say that just omega is equal to 40 pi. So if omega is equal to 40 pi, what is omega? Omega is 2 pi f. You equate it to 40 pi. Pi would cancel out this. 2 would go into 40, 20. And f is equal to 20 hertz. Then the third question, the period. At least there is a clear relationship between period and frequency. And that is T is equal to 1 over F. And this is 1 over 20. And 1 over 20 is 0.05 seconds. You can also solve it using one of the progressive wave equations. So y is equal to A sine of 2 pi ft minus kx. Since we are only interested in this, we are only concentrate on this one. A sine, let's substitute 1 over t for f. So 2 pi t over the period. And so we can compare 2 pi over t to 40 pi. 2 pi over t to 40 pi. So that pi and pi will cancel out. 1 over t is equal to 20. Therefore, t will be equal to 1 over 20. So this would also give you the same result. Okay, but because we have this formula, usually if you find f, do not worry yourself to use one of the progressive wave equations. Then the wavelength. Wavelength can be seen within wave number. So if k is equal to 8 pi, meaning this part of it is equal to 8 pi, or still you can indicate that kx is equal to 8 pi x, and the x's will cancel out. And what is k? K is 2 pi over lambda. So 2 pi over lambda is equal to 8 pi. 2 would go into 8, 4. So we have 1 over lambda is equal to 4. Lambda, therefore, is equal to 1 on 4 which is also 0.25. Are we giving the value of x? No. So we'll assume x is also in meter. Then the speed of a wave v is equal to frequency times the wavelength. We have the frequency, we have the wavelength. So we just multiply frequency, which is 20, by wavelength, which is 1/4. And we have 5 meters per second. If you don't want this, and you want to use one of the progressive wave equations, then y is equal to a sine of 2 pi ft minus kx. Now v is f lambda. Therefore, f is v on lambda. So we have y is equal to a sine 2 pi v over lambda t minus kx. So when you compare, you can say that 2 pi v over lambda is equal to 40 pi. Vivi Papa, mute yourself. So we still have pi 2 going into 40, 20. So v on lambda is equal to 20. Therefore, v is equal to 20 times lambda, which is 1/4. But because of these equations, usually do not, disturb yourself so much. Now indicate the direction of the wave. Because the operators separating omega t and k is minus, it means that the wave is moving from left to right, or the wave is moving away from the main point. The wave is moving away from the main point. Let me see by hands, those of you who scored everything. If you scored every question, sub-question, show by hands. I have 2, Leslie, Nathaniel, Frida. Okay, it's a learning experience for us. Rubin also scored it. Okay. Another question for you. Crispin, okay. Another question. A progressive wave, a plane progressive wave has amplitude of 3 meters. Has an amplitude of 3 meters and a frequency of 150 hertz. And a frequency of 150 hertz. And the velocity of the wave is 220 meters per second. The velocity of the wave is 220 meters per second. Write down the wave equation. Write down the wave equation. So this time, these parameters are given to you to write down the wave equation. I repeat, a plane progressive wave has amplitude of 3 meters and a frequency of 150 hertz. So amplitude A is equal to 3 meters. Frequency is equal to 150 hertz. And a velocity of 220. So V is equal to 220 meters per second. Write down the wave equation. Start work. So another 6 minutes is 4:36. So 4:32, I'm coming your way. We must finish by now because this is not difficult. So let's go through it so you can mark whatever you've managed to do. So y is equal to a sine omega t plus or minus kx, because the direction has not been set. So plus or minus. A is 3, so 3 sine Omega is 2 pi ft plus or minus 2 pi over lambda times x. F is 150 times t plus or minus 2 pi lambda. We haven't determined it, but we can find it because lambda is equal to velocity over frequency. So 220 divided by 150, which is 22 on 15. Okay, so this is times 15 over 22 times x, bracket close. So we have 3 sine of 150 pi t plus or minus 15 pi x over 11. 2 go into this 1 and then 11. So you can also change 11 on 15 to decimal. So you have a final answer of this. 15 on 15 on 11, 1.364 per x. If you leave your answer in fraction, you're also not wrong. Please, how many of you scored this? How many of you scored this? Or got it right? Okay. All right. Another question. A traveling wave on a string. A traveling wave on a string has a frequency of 30 hertz. A traveling wave on a string has a frequency of 30 hertz and a wavelength of 60 centimeters. So it has a frequency of 30 hertz then and a wavelength of 60. Lambda is 60. If its amplitude is 2 millimeter, Michaela, mute yourself. So if the amplitude is 2 millimeter, 2 mm, write the equation for the wave. Write the equation. Hello.
It's 300 pi t, not 150.
I don't get you. Jojo, I don't get you.
It's
Okay. Yeah, I get you. So when 2 times 150, 300 pi t plus or minus 1.364 per x. Okay. Thanks for the notification. So write the equation for the wave. Write the equation for the wave.
Mr. Adrian,
Hello.
please, is the wavelength in meters or centimeters?
Wavelength is in centimeter, amplitude is in millimeter. Frequency is in hertz, 30 hertz. So a traveling wave on a string has frequency of 30 hertz and a wavelength of 60 centimeter. Its amplitude is 2 millimeter. Write the equation for the wave. So this is not much of a problem. All that you need to do, change this to meter, SI unit. Change the amplitude to meter as well. And you are good to go. So using Y is equal to A sine of omega t when solving, you need to take note, read to be sure whether you were told the wave is moving from left to right or right to left. Okay. Nothing like that was said. Usually, for all other directions, if nothing is said about the direction, you can write it as traveling from left to right. All other direction will be said, but if they don't say it, you can also write the wave as moving from left to right. Conventionally, we pick waves to be propagated from left to right always. So if it's the other way around, the question will be clear. Okay. So A is 0.002. Sine of 2 pi times frequency, which is 30 t, minus 2 pi over lambda is 0.6. Please a minute, I'm coming in. Okay, all right, so let's continue. So all that you need to do is this. So 60 per t minus 2 divided by 0 points. Okay, or you can also change 1 over 0.3 to decimal value. So 1 divided by 0.3, this is 3.333, so 3.33 per x. Please, are we okay? Class, are we fine?
Yes.
So this is just it. All right. I've sent you a question. I've sent a question on the platform, which please, you need to do this and get back to me by tomorrow. Send the solution of this to me by tomorrow, because I'll send you another set of questions before Tuesday, okay, next week, okay? So your assignment to be submitted tomorrow has been forwarded, okay, on the page. All right, so this is, work on it, and then you can forward it to me if you manage to finish now. This is where we end today's show. Please, is there any question? Jojo, is there any question?
No, sir.
Mamiya. And note that, please, note this. You can also substitute per 3.142. It isn't, we usually write our equations in terms of per, but if you decide to substitute the decimal value of per, you are also not wrong. Meaning this is 60 times 3.142 t minus 3.33 times 3.142 x. If you write it as such, you are also not wrong. Okay, you are also not wrong. All right, bye then. I'll be expecting your solutions to the assignment. Okay. That ends it for today.